So I'm going to take a moment to explain, if we have a written description of transformations, how we can actually come up with the equation. So I have the problem here where it says, given the parent function f of x equals the cube root of x, g of x be created by the following transformations: a vertical translation up 2 units, a horizontal translation left 5 units, and a reflection over the x-axis. Okay, so I'm going to use my generic notation, g of x equals af of b times x minus c plus d. All right, now from here we just need to identify what a, b, c, and d are. Well, let's start with the easy ones. D is a translation that goes up and down, so that is going to be a vertical translation up and down. Now up, this word right here, up. This word right here means it's a plus, and then it's plus 2. So my D is going to be plus 2. All right, horizontal translation, left. Well, left is going to be a key word, and horizontal is going this way, and that's going to be my C. So this is D here because of the vertical component. Horizontal makes it my C component with the translation. Left means negative, because all of my numbers, if I'm at 0, or that are left of 0 are negative, 5 units. So now I'm going to have a negative 5. Now I've got a minus here because it's minus an x. We're not going to have a b with the cube root, but my f. This last one is my a. Well, from the previous videos, you would see a reflection over the x-axis is actually a negative a. So this becomes a negative in front, so negative a. So now I just clean this up, and my equation is going to be negative f of x plus 5 plus 2. This means it is reflected over the x-axis, and that's because it's affecting the y values. This right here means we're going left 5 units, and then we're going up 2 units. If I wanted to take this and write it in with just the x cubed and not in my f notation here, I would have it as negative the cube root of x plus 5, and then on the outside plus 2. Easy peasy lemon squeezy. All right, now say I wanted to set up the mapping off of this. So my mapping, so the first thing we want to do is we need to know x comma y. We need a point that's going to, that would be on the original parent function. So these are points on your parent function. Points on your parent function. And then we're going to have to plug it into something. Kind of like what we did in geometry. Well, what we're going to do here is we're going to take everything that's on the outside affects the y's, and we don't change the signs. So I have a negative on the outside, so I have a negative y plus 2. And everything on the inside affects the x's, but we switch their signs because of this minus right here. So remember how we had the minus 5 right here, left 5, minus 5? This is x minus 5. From here, we can just pick any points that are on x cubed, put them into this, and get the new points that it transforms to, which then we could actually graph it. All right, so now we're going to actually work on graphing this. So I'm going to use this mapping here, but I'm not going to do it this way because in geometry we had like long lists. I want to kind of put it in a table to make it a little user friendly. So the first thing I'm going to do is I'm going to do x, y, and I'm going to do some values for my parent function. Well, the ones I'm going to pick are going to be negative 2, negative 1, 0, 1, and 2. And the way I get my y values, I plug them in the original function, the parent function. So, you know what? Let's pick better numbers. Let's pick better numbers. Instead of negative 2, let's do negative 8. This way we don't have to mess with decimals. Instead of 2, let's do 8. Let's think about my ultimate output. Let's make my life easier on me. All right, so now I'm going to use negative 8. So if I do the cube root of negative 8, that's negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. And then the cube root of 1 is 1. And the cube root of 8 is 2. Okay, so now I have these. What I'm going to do is I'm going to write my mappings here and here. Right next to my x, I'm going to do x minus 5. And right next to my y, I'm doing a negative y plus 2. I'm going to take this value and plug it in. So negative 8 minus 5 is negative 13. negative 1 minus 5 is negative 6, negative 5, negative 4, and then 3. Here, I want to take my y value, plug it in. So a negative negative 2 is a 2 plus 2 makes 4. A negative negative 1 makes a 1 plus 2 gives me 3. This gives me 2. This gives me 1. And then this gives me 0. So these are my new points. So when I go to graph this, so I'm going to graph this. Now I know that my parent function, just want to graph it here. My parent function looks something like this. And we're going to transform that into a different graph. So this graph would include the negative 8, 2, negative 1, 1, 0, 0, 1, 1, 8, 2. But now I want to do negative 13, 4. So negative 13 and then 4 up here. Then I want to do negative 6, about halfway, 3, which will be up close. Negative 5, which will be really close again. And then 2. And then negative 4, 1. Negative 4, 1. And then 3, 0. So this graph is going to look something like this. So this is g of x, where this is f of x. Not terribly bad once you get used to this process to be able to go from the writing all the way out to making the mapping, creating a table, being able to go from the graph. So you're going to have to go all different ways. I can give you the graph, and you should be able to give me the mapping and the written equation. I should be able to give you the mapping, you can give me the written equation and the graph, all those different options. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.